We know if you want to check the continuity of the function, you can also use a different method in which you can take your values, your x is equal to xn equal to 1 minus 1 over n, and each time the value will be different, because you if you apply limit on this value, then you will get the actually we have checked the limit of we have to check the limit on x is equal to 1. So we have got that sequence for that value. We have supposed that value to find the limit of that sequence, that was f of x equal to x for x is less than 1, and f of x is equal to 2 plus x minus 1 square for x is greater than 1. So we should keep in mind that for each function we will consider a different value of n, and we will put x is equal to some different value of n, because the function should approach 1 when you apply the limit. So this value we have supposed, and we have put into the functions. We have put into the first function, then we have put into the second function, and we have basically this 1 over 1 over n actually shows the left limit of the sequence. You can say if function is what was the left limit, this was the left limit, and we have put actually we have suppose xn is equal to 1 minus 1 over n for the left limit, and in case of left limit x is less than 1, so we are putting 1 minus 1 over n for the left limit in the function. So let's put, so if we put in the function and apply the limit x n approaches to infinity, then this will be limit x approaches to infinity, limit x approaches to infinity, this will be 1 minus 1 over n, 1 minus 1 over n. If we put 1 minus 1 over infinity, this will be 1, this will be 1, and this will be 1, and we have got the left limit. And for the continuity we have to check left limit and right limit, and then we have to show that left limit or right limit is equal to the or not. Mm, so for continuity, we first check the function is defined on that value or not, and then we have to check that left limit is equal to the right limit, and it should be equal to the equal limit. If these conditions satisfied, then function is continuous. So we have got the left limit which is equal to 1. Now for right limit we have put x n, so it was equal to what value? So actually it was equal to the x n 1 plus 1 over n, and if we put limit x n x approaches to infinity, then we have put x is equal to x n is equal to 1 plus 1 over n in the function. We are putting in the function that value in the function. So we have checked the left limit in the first function, then we are going to check the second limit in the first function. So let's check the second limit in the first function. This will be limit n x approaches to infinity 1 plus 1 over n, and this will be again 1 plus 0, this will be 1. So left limit and right limit for the function f of x is equal to x are equal, but now let's check the right limit in that function. So we are using the same process that we have used. We have to check the left and right limit in the first function, and then we are going to check the right limit in the right function. There, what is the right function? That is right function because in which in that function x is greater than 1, and that is called the left function. that is called the left function, because here x is less than 1. So now we are going to check the limit. We are going to put xn is equal to x is equal to 1 plus 1 over n in the second function. So this will be limit f of xn equal to limit 2 plus xn minus 1 square. So if we put xn is equal to 1 plus 1 over n, then this will be limit 2 plus 1 plus 1 over n minus 1 square, and 1 is cut with the 1, and this will be next value will be what? Actually the next value will be limit 2 plus 1 over n square. This will be 2 plus 0, and this will be 2. So left limit, the limits are not equal because the both left limit were both the left and right limit in the first function were 1. Answer of them were 1, but answer of this is 2, so they are not equal. So it means that function is not continuous. Okay, so function is not continuous. So now let's do another question that was actually we are going to do that. Okay, basically the function was, again we have another function that was we are going to apply the limit definition on that, and we are going to check. We are supposing another n value for that.